Thank you very much. Right, well, thank you for joining us today. So, apologies for those who've all been to some of the other sessions, because you will recognise the intro. It's much the same intro, but it'll only be for a couple of minutes, and then I'll hand over to David. Now, I've been in the IT industry over 21 years, and you can probably guess from like how care I look now. So I've been delivering projects in Java and C#, JavaScript and C++ many moons ago, and those languages have evolved. But there's a whole world of other languages out there. In general, we seem to get stuck around a few key languages. And we love technology, and technology changes so quickly. I mean, mobile phones, televisions, everything changes so quickly, but our languages don't seem to have changed as quickly as technology itself has. And sort of, well, why are we still sticking with these languages? And that was kind of the thought I had a couple of years ago that led me to kind of think about this series. David? Thank you. Yeah, cool. So today what we're going to do is we're going to do a little bit of an introduction to Challenger languages and what they are. I'm going to then hand over to David, and he's going to give a bit of a brief sort of history and summary about what Go is. He's going to do a bit of a live coding demo for you, go over some of the pros and cons of it, and also give you some next steps. And we'll be sort of 5 minutes or so at the end for if anybody has any questions, or if they just want to provide their own experiences with Go. You know, sometimes we have people on these calls who've got experience of using these languages. First, I think we'd like to go over sort of who we are. I know there are some Andys online. But, this is my esteemed colleague, David Johnson. He's a PD at Product Developer and Digital, and he will be doing the bulk of this talk. I'm just providing the filler at the beginning while people file in. I believe your title is "and first-time father," isn't it, David? So you're probably having a sleepless night.
That's why I look a little bit drained, right?
It's also that monitor town as well. Do you want to move on? Thank you. Yeah. I'm Jeff Watkins. I'm Chief Engineer and electronic musician. So I make techno in my spare time, but don't worry, I'm not going to subject you to that today. So I'm digital in general. Who are we? Well, we're a technology and product-focused digital consultancy. We're around, sort of, I think, maybe nearly 750 people now. We're currently growing. Majority of whom are actually in delivery roles, so we're actually a very delivery-focused organisation. We're not a management consultancy. We have over 300, probably nearly 400 technologists, which is great. But this is the key thing for us. We're technology agnostic. We're not a Java shop, not a C# shop. We're technology agnostic, which means we're always looking for different technology trends and accelerators in the market. I'm part of the Tech Impact group, so I'm looking for, well, what's coming next? What can we do to help deliver better products, safer, higher quality and faster for our clients? We help our clients navigate change in the digital arena. We build the right products for them, and we help upskill their teams as well at the same time. You know, we believe in building capabilities in our clients. So we have three core pieces: guide, build, and teach. Guide is our kind of traditional consultancy arm. So they go in and look at things like digital strategy, API strategy, and how we can help them transform their ways of working. We have a dedicated agile coach team as well. Build is where the majority of people in AND are the people who actually deliver the software. They deliver the software, deliver these digital products. And teach is the element of AND where we actually help provide courses. We also have onboarding, award-winning onboarding and academy provisions. We actually try and help close that digital skills gap. Our ambition is to try and help upskill 200,000 people by 2025, which is a huge ambition, but I think it's a good ambition to have rather than just become big or rich. So a little bit of sort of logistics here as well, and recording this. If you are not comfortable with your face being recorded, please switch your camera off. Some of these things might be used for promotional material. Also, this recording will be available afterwards for those who couldn't make this talk. So that's part of it. This is kind of a reference as well for later on. We might take the old screen grab as well. If you are not comfortable with your face being screen grabbed, please just let us know if there are any issues. Yeah, so just kind of generalized code of conduct. This is a positive and safe environment. Please keep everything respectful and also on topic. Everything's equal and inclusive here. We believe that diversity in technology is a very good thing. We believe in a strong community presence as well. So we're all friends here. I mean, we've had no issues so far with anybody, any conduct, any of these events. I think we're all friends here. There's no stupid questions. You can ask whatever questions you want at the end. There are no stupid questions. There might be questions we can't answer, which are probably good questions, but you know, we will try our best. Both of us will try our best to answer the question at the end. But also, if anybody else has anything to discuss or you know, any of their experience pitching, please feel free. This is an open and welcoming environment. So I just ask, while we're doing the talk, please stay on mute, just kind of keeps the crosstalk down. I'll go on mute after this. If there's any questions, there's a little chat pane in Zoom. If you look at the bottom of the bar of the chat, so just type in any questions you want during this, and what I'll do is I'll read out some of the questions at the end and we'll try and answer them. If you have to dash 11:45 on the dot, that's fine. There's a chance you might overrun depending on the questions, but don't worry if you have to leave on the dot. That's cool. So here's the itinerary. You can see we're getting close to the end of this series now. I believe all of the other ones are available recorded. I did the previous one on TypeScript. Router started it very strongly with Kotlin, which is a great demo. And George Rakaishaw did something on Rust, which is a really interesting language before that. As mentioned earlier on, we've got one to go after this on Clojure on the 24th of September, which is a really fascinating language. Our speakers have taken a lot of time to sort of hone these presentations and present these demos. So I really hope you're as appreciative as I am of the amount of effort that's been put into this series. These are live code demos, so there might be mistakes. You know, I always say don't work with children, animals, and live code. But really, why are we discussing challenger languages and kind of what is a challenger language? So here is what's called the Toby Index. It's named after the Oscar Wilde play, The Reports of Being Earnest. And this is the list of the most popular languages in the world. This is based on check-ins and Google searches, I believe. There are other ones. There's Red Monk and Pipl as well. So, but in general, this is actually true that Java is somewhere near the top. C has the most lines of code, probably because it's a more verbose language. You know, it's a simple language. You need to write a lot of code. But there's a lot of embedded going around as well. So that's why you probably see so much of it. But what's interesting is when people asked me originally, well, why aren't you including Python on this? Well, if you look there, it's number 3. If you look at the other indexes, it's number 3 or 2. So it's not really a challenger when it's one of the, you know, it's so high up there. So if you look at the top 10, well, none of the languages we're talking about here in the top 10 still offends me to see PHP there, but it's nice to see it going down. Apologies to any PHP developers on the call. So, okay, please. Now here we go. This is the Stack Overflow survey for 2020. Here's what our most loved languages are. Now, if you notice, there's very little crossover between the most used and the most loved. In fact, almost none. JavaScript just sneaks and C# sneak in there. But Rust, TypeScript, Kotlin, and Go are all there in the top 10. All most loved. It's what people also there's the most wanted index as well, and people love that. People love it and want these languages. These are the ones that developers want to use. Really, the top intersection there is clearly Python. Python is very popular and it's also loved and wanted. You know, people really like Python. So, okay, smooth. Cute. Now, here's the most dreaded. Now, notice here there is actually some of the crossover in the most dreaded. Java's in there. C# doesn't quite make the cut. I think it's like at number 50 or something like that. JavaScript's in there as well. I mean, no surprises, VBA is the most dreaded. Yeah, just don't blame people on that. But, you know, so actually some of them, our most dreaded languages are kind of also our most used, which is slightly worrying, isn't it? So we're not always using, in fact, quite often not using languages we really want to use or love. But why are there so many choices? Why do we choose one language? This is my final, I think it's my final slide. I'll shut up. So just for people who aren't as familiar with sort of what we call programming language paradigms and things, there's different paradigms. There's functional, there's O, there's imperative, there's declarative. Also, some are interpreted. I mean, traditionally JavaScript's interpreted now kind of a little, because the V8 engine does some optimization. There's an argument to say it's kind of semi-compiled. But we've got things like the basics and the Lisps that are interpreted. They tend to be lower performance. You've got your compile languages. Go fits into there. C or C++. They tend to be, you compile it for a platform, it runs on that platform. You have to recompile it if you want to run it on another platform. Then you've got kind of what we call the VM-based languages, the ones where it's supposed to be write once, run anywhere, where it creates some kind of intermediate language, or bytecode or IL, depending if you're doing JVM or .NET CLR-based stuff. So obviously you've got your Javas and your Kotlins and the Scala and the Clojure. There's basically a bunch of ones in there that are very familiar. VM-based languages are kind of quite popular at the moment. I think due to that, due to us moving between kind of people developing on Windows, on iOS, on Linux, you know, this run anywhere thing. People think of these garbage collector languages, but even compile languages have garbage collectors as well. They just have different types. That in itself is a separate topic. So this is the kind of the broad, you've got the different paradigms, and you've kind of got the different styles of whether or not compiled, interpreted, or VM based. And they serve different purposes. You might not want a JVM, big JVM running on a very, very tiny system. So without further ado, I believe now I'm going to hand it over to David.
Cheers, Jeff. So as has been discussed already, I'm going to be talking about Go, sometimes known as Golang, which is the name of the actual website that Go is stored on. You can use the names interoperably, but the official name for it is Go, just worth mentioning that. So, a bit of a history on Go. It came about because three clever gentlemen at Google looked at all of the different languages Google used and decided that they wanted to take all of the best and strongest bits from all languages without all of the undesirable bits that they didn't really need. So what is Go? Go is an open source project. So it's available in GitHub and built by a team at Google along with some open source contributors in later years. And it is built around the idea of developer productivity. It's designed to make it easier for developers to write efficient, clean code, and to make it quick for them to do that, because then they can get more code out there. And it is a statically typed language, even though it feels through type inference, it feels a little bit like a dynamically typed language like JavaScript. So why was it created? It was created to be statically typed and runtime efficient, like your compiled languages such as C++, but have the readability and usability of languages such as Python and JavaScript. It does support very high performance networking applications and supports multiple processors, which gives itself a high level of concurrency. And it contains very little garbage in its libraries as possible. This last point is that noted that when the three guys came up with Go, they had a bit of a mission statement that any feature to go into Go needed to be agreed by all three of them. And the idea of this is if all three of them didn't agree on it, it wasn't a feature that was really needed, so it didn't go in. Only stuff what were needed went into Go. So who uses Go? There's only one or two companies out there that use Go because of how new it is, which is a little bit of a lie because there's absolutely loads of them. You've got some very big names in there like Netflix for video streaming services, financial institutions like American Express and PayPal. You've got social networking in there such as Twitter and Slack. And you've got CI/CD pipeline and containerization, infrastructure support, technology companies in there such as Kubernetes, Heroku, and Dropbox. Kubernetes, Heroku, and Docker. It's worth noting that Kubernetes is actually written in Go. So it's actually a really good example of how Go has made its way in the market. So what is Go good for? It's good for distributed services. It's got a robust networking language and handles streaming socket-based streams, as well as HTTP client-server requests and other requests such as WebSockets, RPC, pretty much anything. And it also has HTML templating with escape variables, which you can see from the coding example at the bottom. It has excellent support for the common serialization format and encoding formats, such as JSON, XML, hex, binary, base64, among many others. And from the coding sample, you can see it's really easy to utilize this serialization and encoding. Concurrency, it is very good on high levels of concurrency, utilizing channels and mutexes for locks and waits to make sure that you can use multiple threads and bring them together in a nice, safe way. And it supports Go routines, which is Go's version of a coroutine, fibers, lightweight threads, and supports millions of these in the same address space, allowing for a lot of waiting and scheduling of your commands and processes. And it provides similar performance to your typical event-driven asynchronous languages, but written in a more procedural coding style. Productivity is a big thing for Go. It is one of the reasons, one of the main sort of talking points of Go and why it was created. Its language is simple. It's quite simplistic, which sometimes can be a drawback. It implicitly implements interfaces, which is a very good important point of Go, that you don't have to hook up your interfaces. It's just any object that shares the same properties or functions as an interface, implicitly implement it, so you don't have to hook it up manually. There's no classes or inheritance in Go. It is composition only, which is one of the major differences between a lot of the more popular languages. And there are no generics, although there are some cases where code generation or interfaces are used in order to try and get around this. And it does contain garbage collection. Its tooling has inbuilt unit test benchmark code generation tools, which make it really easy to generate code and make sure that the code is of good quality with your testing. And you can import packages from Git repo. It also now has proper dependency version management as well, which is something quite recent for it. Packaging wise, as Jeff said, it is a compiled language, so it compiles down to a single binary executable, but it can do this for many, pretty much all operating systems and all architectures, so Linux, Windows, x64, x86, whatever. But it is worth noting that you do have to recompile it for your target framework and platform each time you build it for that interoperability. So what is Go not good for? It has no generic programming syntax. So that, in order to replicate this behavior, there's a lot of boilerplate required when you're working with containers. Sometimes code generation is used as a workaround, or clever uses of interface and reflection have become quite common to try and implement this. Verbose error handling. It uses error return values, which is more akin to a sort of an optional error result, where you get an object back and you have to check if it's in an error state or not, and then handle it that way, as opposed to other error handling techniques that you get in other languages. but it does this without the convenient chaining that you sometimes get. And it does require more boilerplate to handle errors for each call because of this. It is worth noting at this point that there are additions to error handling planned in Go version 2. Not to say that Go version 1 is not still being worked on, but this is something we planned for Go version 2. It does have the defer, panic, and recover error functionality, which is a bit like your try, catch, finally blocks in languages like C#. And performs stack unwinding on error handling, and it is only intended to be used for unexpected runtime exceptions. It's not really intended to be used for logic flows to report errors out of your API or whatever. And it's not particularly elegant. As you can see from the function below, it's not really clear straight away, as it is with your try, catch, finally in the nice hierarchical style that they are in, as to what parts do what. You have to really look in and read about what's happening there. In terms of GUIs, there's no standard library for GUIs, for creating GUIs in Go, and most libraries that do exist for creating GUIs in Go are just wraparounds of C and C++. So you have to be careful when you get in one of these libraries that the managed and unmanaged memory is handled correctly. And it's not that difficult to create the UIs, but there's no single standard or story for creating graphical apps in Go. It's probably worth noting that it's not what Go's designed for. If you're wanting to use create graphical elements, Go's probably not the language for you. So you'd probably want to go with a different language or use Go as a backend in conjunction with some other sort of front-end language. So on to the live demo, which is where everything always goes swimmingly well. So I'll start off with my Go playground here. This is online for anybody to go and have a play with Go, and it's hosted by the developers of Go. So you can see here quite a simple function. We're importing, naming it package of main. This is like a namespace, bringing the imports that we want, and then our function to print to the terminal or console. So I run this, everything is fine. Hello playground. As I've said, one of the important aspects of Go is waste management. We don't want very much waste in our code. And one of the sort of talking points of Go is the fact that it doesn't just warn you like a linter if there's an unused variable, but it won't actually compile. So as you can see on the screen now, I've commented out this line of code. This import isn't used. So it's not going to compile for me. It's going to force me to remove that waste before it will compile, which is quite unique from what I've seen. The reason I'm showing you this in the playground is because my compiler has some auto formatting tools on, which will just take the unused import out. So I can't actually show you there. So moving on to my coding examples. This is my my Go application, and just on my main application, I'm going to create a new person object called David Johnson. Great name that person has, and set it to a variable of type organization identifiable. So if we look at the person object, it's in the package organization. This is our namespace, and I've got imported, got my free imports, which must be used, otherwise my code won't compile. And I've got a type of identifiable, which is an interface. And in our interface, we've got a single function, which is a string. In my person structure, remember there's no classes in Go. Structure is the closest we're going to get. I've got first name, last name, Twitter handle, and alias. So because there's no classes and there's no constructors, I have to create a function in order to populate this. So in this case, I've got a function called new person, which is passing in my first name and last name. And from this, I am just going to return a person object with these values set. And you can see this syntax is very similar to how we put in quite simple, similar to how we put in JSON values in JavaScript. Now, that gives us our new person object, but what about our ID? So at the moment, we have not got an ID function in here, and the identifiable interface that we're passing it to does require the ID to be used. So in this case, we actually can extend the structure by using this function here, passing in the person object, giving the function a name, and defining what it's coming out as. So in this case, it's hard-coded to 1, 2, 3, 4 when we pass in the person object. We run this. And we get 1, 2, 3, 4 coming out exactly as expected. So because we've extended this structure so that it now has the function ID, it's explicitly implementing this interface. The reason I'm having to define it here is just because it uses type inference, and if I didn't use that, it would infer it as a person structure. So because it has this function on it now, and we've got this interface, implicit implementation of the interface, so variable P now has this function that we can print. One of the things on this as well to note is the var keyword and the type. This is one way of defining a variable in Go. But if we go to my second example, we can see I've just used P : equals. This is also a brand new variable declaration, and it is implicitly picking up the type from the returned object. So in this case, P is going to be a person. Just like before, we've created a new person. Now, in terms of error handling, I'm going to call a function called set Twitter handle. So again, back into my person file, you can see here I've got a couple of extra functions. Full name, which will return my first name and last name, using sprintf, which uses these markers to inject in the values. Set Twitter handle, which is doing a bit of validation if I've actually specified a value, meaning we can have blank as a valid value, and it doesn't have a prefix of @, so all Twitter handles must start with @, then we're going to return an error. So you can see this object returns an error. And this is where the error handling has its downfall. And you can see, to say that it's not got an error, I just return nil. So here, if it's valid, I set my Twitter handle to handle. And down here, we've got another function called Twitter handle, extending the person object again, and we're just going to return that Twitter handle from the person object. So one more talking point on this is, in the terms of the ID, I just passed in the person object, and it returns a static value. But in the case of these values here, particularly the set Twitter handle function, we've got a star before the type. And this is because this is a pointer. If you don't use that, we're going to get a brand new object. So in this case, we've got a brand new object of the person passed down into this function. The fact that we're just returning 1, 2, 3, 4 doesn't really matter so much. But in set Twitter handle, if we pass down a brand new object, the original object doesn't get modified. So we're going to set the Twitter handle. But then when we call the Twitter handle function, we're not actually going to return the Twitter handle. It's still going to be blank because this has been set on a different object. So in order to use the original object, we use the star as a pointer to reference the original object. And this will modify the object that we passed in, and not a copy of the object we passed in. So going back onto our main application, you can see here that we return our error object from the function. And if it's not equal to nil, we're going to handle error manually and just print something to the console, and then return out of the function. If it is valid, which should be the case because we've got an @ and then my name, my Twitter handle, it's then going to print out our alias, our Twitter handle, our ID, and our full name. So if we just run that now. You can see that my alias is anonymous, my Twitter handle 123 and David Johnson. Just to give an extra bit of an example on that, I'll just go back to Go, remove my pointer, and then run our function again. And you can see there that because I'm not using the pointer anymore, I don't have a Twitter handle. The other talking point on this is some of these are functions which we've extended from the structure. And then we've got an alias, which is just coming from the structure itself. It's not a function. It's just a default value on the on the structure. So if you see in here, we've got alias, Twitter handle, first name, and last name. So why don't we just return Twitter handle if we wanted the Twitter handle in this case? Well, if we have a look at the autocomplete, you can see this is what we've got. We've got our three functions and the alias. So why is this? The reason this is because alias is in Pascal case or upper camel case with a capital at the start. The others are in camel case or lower camel case. This is inferring that alias is public, but these three are private. So if I change first name to have a capital start letter and save it, I go back to my autocomplete and one first name appears because it's now public. So that's another unique feature, or not unique, but an uncommon feature of Go. So setting that back, there are just two other examples I want to cover, which are more complicated data types. The first one is called an iota. Now, an iota is an incrementer. Starting at 0, every time you call it, it'll give you a new value. So you can see here, I've got a global, which has an iota of 1 for the first variable and an iota of 2 for the second variable as constants. But it is scoped as well. So if I start using that iota in another scope, like here with our local constants, iota value 1 and iota value 2, it will have start at 0 again. So it uses the iota inside of the scope of the object that you're using. And you can see this based on the example on here. Sorry, that's not saved. You can see there we've got 0, 1 and 0, 1 instead of 0, 1, 2, 3. The second complicated type is complex numbers, which you can do in Go really easily, which aren't always easy in other languages. So if we look here, we've got our complex value is equal to complex number of 1, 2. So in here, we're creating the complex number with two floating point values, a real value and an imaginary value. And then if I print out that complex value, which you might have seen the spoiler from when I ran this before saving, you can see it brings out the complex value, 1 plus an imaginary value of 2. So that makes it really useful and quite popular for mathematical applications, given its high levels of concurrency, speed, and the fact that it can handle stuff like complex numbers. So that is the end of the demo. Going on from that, where do we go from here? So there are still ongoing developments to Go version 1. Just because version 2 is in the pipeline, it doesn't mean that version 1 is done. In fact, the latest revision was just last month. Version 1.15 was released. Go version 2, there's some major improvements coming along. One of them is the generics, which have been missing in Go version 1. There has been quite a bit of controversy about this because some fans of Go think it goes against the ethos of Go, adding in these generic types. But it does look like it is a go. Also, simplified and improved error handling. You've seen that error handling isn't great in Go version 1, so they're aiming to add more to this and make it easier to use in Go version 2. One of the things they've also decided is that Go version 2 must be interoperable with version 1 and work alongside it, so that there'll be no breaking code changes. And in addition, there are other minor features and enhancements in Go version 2. If you look on their GitHub repository, there are 141 open proposed features for Go and 349 already closed ones. So there's quite a lot going into Go 2. So you would have to go into the GitHub repo to have a gander at all of those different proposed features. Key points about Go. As we've covered, it is a simplified type-safe language. It has minimum waste. It forces you into minimum waste and not just warns you about it, which is quite good, especially seeing as we're compiling down into a single binary executable. Its implicit interface implementations means that if you add in more interfaces, you don't have to go around the houses to implement that everywhere you need to. It'll just implicitly implement them. And it has type inference, much like JavaScript. It has got type inference. However, with that type inference, it is still statically typed. So it is not mutable. They're immutable objects once they've been set with a type. And it can provide high levels of concurrency, which which is why people like Netflix and Kubernetes use it, because it is really good for those concurrent high-level networking distributions. But it's not really designed for creating UIs. If you want something that creates UIs, go with a different language. So next steps for anybody who wants to look into this a bit further, we've got the main Golang website, which is golang.org, which has the online playground I've used, as well as the download of Go itself, as well, and documentation for installation and getting started. The GitHub repo link is on the slide there, as well as the wiki for Go version 2 with the information on what they're planning for Go version 2. And just to make things easier, the bottom link is just a link to the Go version 2 GitHub page issues, which filters on proposed issues for version 2. So it just shows you the list straight away for Go version 2. And do we have any questions in the messages at all?
Got one here. So does the implicit interface implementation work on more than one interface at a time? So can you do multiple interface implementation?
Absolutely. If a type matches the signature of an interface, it will implicitly implement it. If that means that if it matches multiple different interfaces, it will implicitly implement all of them.
Cool. Do you know of any sort of maybe killer applications for it sort of in our context? I know, and we've done a little bit of Go. Do you think of any sort of good use cases from our point of view?
Really quick delivery and turnaround of sort of cloud-based solutions, particularly distributed networking and concurrency in there.
Cool. Anybody else? You can unmute yourself now if you want to, or you can type into the chat. I don't mind. Silence. Does anybody on the call have experience of using Go, or are they interested in using it? Cool. Alexander's interested in using it, yeah. I think it is growing in popularity. I mean, it is on an upward trend. Most of these challenger languages are. I think in a year's time, we'll have to pick a new set of languages because things like TypeScript, Kotlin, and Go are actually definitely on an upswing. Which is good. You know, I don't think I will shed any tears when we finally stop doing Java projects. Frankly, apologies to any Java developers.
Or PHP, Jeff.
Yeah.
Apologies to any PHP programmers.
Yeah.
They've suffered enough. I'm sorry.
Oh, thank you very much. Unless there's any further questions, I think we can probably stop the recording. Oh, here we go. Oh, no. Kenneth Stewart. Is that the BGSS Ken Stewart, or is that just a different Kenneth Stewart? Are Ann Digital... Different one, okay. Are Ann Digital using Go in any of their current projects? And what have the client's reflections been?
That's probably more of an answer for you, Jeff. You might have a bit.
Yeah, so we are using it. We're using it quite a lot for DevOps on clients, actually. And because it's kind of in the DevOps sphere, clients themselves are less exposed to it. I don't think we're using much in the way of like public-facing solutions. We're using it as an accelerator for very quick, basically in the kind of the shared tooling area. And when we're building like a cloud center of excellence, we'll quite often build because it's a very productive language and it's kind of suits that kind of DevOps ethos of getting stuff done quickly and cleanly. We are using it quite a lot in that space. It would be nice to get more use of it in kind of make more use of the networking features. I think, you know, the networking concurrency features on when we get something in maybe like the media space, things like as the example of Netflix there, something in the media space would be quite interesting to put it to the test in that.
I mean, I think Go's going to become gain. It's already gaining traction as we've seen, but I think it's going to get a lot more traction because it's now proven. It's got some really big names who use it on a wide scale, like Docker and Netflix. So it is going to it is sort of proven out to be quite good at a large scale sort of content delivery. And like Jeff said, your DevOps tooling, and it is very minimalistic, making it very quick for developers to be able to knock out a bit of code that will do something.
Yeah, I think he'll probably see even more use if it becomes like the go-to boom language for a particular platform. You know, like obviously Android has chosen Kotlin, and you know, you can use Node.js with TypeScript and JavaScript as well as Python for AWS Lambdas. So I think if it once it's found its kind of killer app in a shared tooling, then it will probably really take off. Cool. Well, thank you very much, everybody. We'll be on the call for a few minutes after people start filing out, if anybody wants to have a chat or ask any further questions, because you're a little bit shy doing it in front of everybody. Thanks, David.